Hello friends, this is my third video about SDXL, and in this video again I want to review the features and improvement, and also I want to share my latest workflow with you. Okay, in the Stable Diffusion SDXL we got some improvements. Some of the improvements are about the resolution of the trained image, that they are with 1024 in 1024 pixel. And also we get improvement about the clipping text, or the part of the engine that is translating your prompt to meaning and to concept that AI can understand that. Okay, so with improving that part, we can write prompt with easier and with simpler language. And also you can see that that now we have two different models for Stable Diffusion. One of them is base model and one other is refiner. The base model is trained with 3.5 billion parameter and the refiner is trained with 6.6 billion parameters. So the parameters in the refiner model is higher than the base model. Okay, and this is the reason that we have to combine these two models together. And also it's possible to use the Stable Diffusion SDXL with 8 GB VRAM. Okay, at first let me focus and give you some explain about this feature, more intelligent with simpler language. Okay, here I have some information for you, and I will place the link in the description, and you can see the SDXL and also SD 1.4 and SD2. If you focus on the text encoder, you can see that SDXL is using CLIP ViT-L and OpenCLIP ViT-bigG. But in previous version of the Stable Diffusion, only we was used CLIP ViT-L. Okay, so OpenCLIP ViT-bigG is added to a Stable Diffusion. And also, still we have the CLIP ViT-L. Okay, so now we have two different text encoder. And what are the text encoder? Okay, let me explain to you. For example, you are writing your prompt. The machine and the AI should understand what are you typing. Okay, for example, compare the ChatGPT version 3 to version 4. When you are writing and when you are chatting with ChatGPT version 4, you can figure out that the ChatGPT version 4 is very smart and it can understand what are you talking about. And it's the different, exactly this is the different from different text encoders, because they are the most important part of the AI, because they can understand the text and they are analyzing your text and converting your text to the codes. And also they have some limitation. CLIP ViT-L was used in SD 1.5, and you can write your prompts exactly with the same format that you had in previous version. But in OpenCLIP ViT-bigG, you can write your prompt very easier, and you can write your prompt as a sentence, and you can describe what you want in human language, and it can understand. Okay, but still they are not working perfect. Okay, so it's just beginning of the game. Okay, and it is not the final point. I think they are trying to figure out that what is the best combination between these two models, and after that they will take the decision. But at this moment we have to find a solution to use the benefits of both these models. Let me explain to you something easy. Okay, I went to the bard.google.com and I asked the chatbot that what is the difference between two different model. Okay, and it told me that the CLIP ViT-bigG has 137 billion parameter and ViT-L has only 90 billion parameter, and the accuracy of the bigG is very better. Finally, after asking many questions and also searching over the internet, I asked him, for example, to provide some prompt sample for me. Okay, and after asking, it provides some sample for me. Okay, the upper part is the sample that I can use for the G model. Okay, and this prompt is very good for using in CLIP L. Okay, so you can see the difference. The upper part is a complete sentence, but the prompt that I have here is some tokens or some words that are sitting near together. Okay, so it's the difference between the CLIP G and also CLIP L. In ComfyUI, wait please, okay. In ComfyUI, we have some text encoder, CLIP text encoder, SDXL. Okay, this text encoder is specially designed for the SDXL. Okay, and here you can see you can write prompt for CLIP G, and also here you can write your prompt for CLIP L, and it will process these two prompts separately. Okay, so you can write your prompt here with the rules of CLIP G. It's very simple. You can write that as a sentence. And also the CLIP L is the rule that previously was used in Stable Diffusion 1.5, for example. So you can use them. And how you can use this CLIP text encoder, you can load that, and also directly you can write your prompt in this text box, or you can right click on this node and click here, convert text G to input, and convert text L to input. So here you can see the text box, and we can send the prompt from some other text box inside the CLIP text encode. Okay, and exactly this is the technique that I am using. And let me show you my workflow. It's very, I think it's very easy and it's very useful. Here I have two text box. It could be one text box. Okay, don't worry about that. It's only for myself. And I merge the text from these two text box with the text concatenate from WAS. Okay, here, and here. Text concatenate. Okay. With this node, you can merge the text. Okay, and here you can see that I tried to explain my prompt as a sentence. After that, merged them here and send them to the CLIP G. Okay, and the prompt that we need to use for inside the CLIP L are contained from tokens or words that are separated with comma, with a space, and it's very old style, and you can connect that to the text L or CLIP L. Okay, so this is the way that we can using the CLIP text encode, and it was the important part. Okay, and about the refiner, we have a different CLIP text encode. Okay, if you write here SDXL, this is the CLIP text encode SDXL refiner. And you can see for the refiner, we don't have any CLIP L or CLIP G. Okay, so it needs some information for processing and adding the details. Okay, some of the people's only using the prompts for CLIP L, and they are sending those prompts to the refiner. But based on my experience, I prefer to merge all the positive prompts, and after that sending them to the CLIP text encode SDXL refiner. Okay, it's dependent to you. Sometimes you can merge them, or sometimes only you can connect the CLIP L text box. Okay, it's completely dependent to you. And another node that I used here is the Lora. Okay, and also it's very important because the Stability AI company suggested to use this Lora. Okay, and it can help us to get images with some more contrast, and you can download the Lora from the file, from the link that I have placed in the video description. Okay, this is my checkpoint. The checkpoint is connected to Lora, both model and CLIP. The Lora is loaded, and the model is connected to the sampler and also the CLIP text encode. First, I want to explain all the workflow, and after that, I will delete all of these nodes, and we can create all of them one by one. It could be very easy. Okay, for the base model, I'm using this sampler. Okay, and my scheduler name is DDIM, and the scheduler is DDIM uniform. For the refiner, and also please pay attention to this parameter. For the first one, add noise is enabled and return with leftover noise is disabled. For the refiner, add noise is enabled and this one is disabled, exactly same as the top one. Okay, and I use this sampler. Okay, and there is only one difference. In ComfyUI, we have two different sampler. One of them is K sampler, and one other is advanced sampler. In advanced sampler, you have two parameters: start at a step, end at a step. You should define them, okay? But in K sampler, you don't have them, okay? And these two parameters are defining that how many samples and how many steps should be processed with this sampler. For example, this sampler is starting the processing from step 1 up to step 20. After 20, it is going to send the process data to another sampler, and this sampler is receiving the data. But in this sampler, I have configured that, okay, start processing the data from step 20. It's very important, because if I want to start processing the data from step 0, after that it can generate another image for me or something different, okay, or maybe it can make some problem for me. So when you are working with advanced sampler, one of them is processing the data for a specific step, and after that sending the sampler, sending the data to another sampler, and that sampler is starting the processing from the previous step. Okay. Totally in this workflow, I'm using 30 or 25 step, not more than. Uh, and after that, I used upscale method, very simple. Okay, I used, here you can see the process. I get the image from the sampler. I send the image to VAE decode. After that, I send the image to the upscale image using the model. I use this model for upscaling, and after that, I downscale the image by half amount. And again, I send the image to the VAE encode and send the image to another sampler. Okay, so this sampler is making the upscale for me. And also this sampler is starting from step 20 up to step 30. So also for the upscale, again, I am not starting from step 0. It's very important. And here you can see that the image that is generated really is in high quality, and also the details are very sharp and interesting. Okay, and only I use the 2 checkpoint. One of them is base model of the SDXL and one other is refiner. Okay, here is the refiner. But for upscaling, I use the base model. Okay, you can test that, you can do the upscale with refiner, but you can see that it makes some problems for you. Another important part in this workflow is using the VAE encode tiled, okay, and also VAE decode tiled. When you are using this kind of VAE, it will use very low amount of VRAM. And for example, if your graphic card is only 20 gigabyte or 16 gigabyte, okay, really it's better to use the VAE decode tiled version for the upscale. It's very important, and also I can show you in my benchmark window and you can see that. Okay, so the space is empty and I want to add all the nodes, and also I will try to explain all the nodes one by one. Okay, at first I am loading checkpoint. Okay, and from here I am using the base model. I can make a copy, and also here I can load the refiner. For the base model, okay, it's, if you want to load the Lora, you can send the model to the load Lora. Load the Lora, it is SDXL offset. Connect the clip to the clip, and after that you can connect the model and also connect the clip to the sampler. And for the sampler, I'm using the advanced sampler. So the model is connecting to the model, and now I have to make the positive and negative prompt and also the latent image. For the latent image, I'm using empty latent image with the size of 1024 in 1024 and batch size of 1. Okay. For the positive and for the negative prompt, I have to open and load the clip text. Okay, This is normal clip text encode, and you can use that for the negative prompt. Okay, and let me connect that to the negative and change the color to red. And for the positive, I told you that we need clip text encode SDXL not refiner. Refiner could be here. SDXL. Okay, this one. Okay, so the simple clip text encode SDXL will be used for the model that is connected to the base model. From the internet, I figured out that it's better to change the width and height of the width and height to some higher amount and keep the target width and target height in same amount. So it's for positive. Let me change that to green and connect that to the positive. Let me make more space here. Okay. And I don't want to write my prompt inside this node. I want to write my prompt in a text box and after that send them to the clip text encode. For writing my prompt inside the text box, I have to install the WAS suite, go to the text and add this node, text multi-line. Okay, and here I can write my prompt here. Also, let me change the color to green and convert G to input and convert L to input. Change the title to G and this one to L. Okay, so I can connect the G to the text G and the L to the text L. Also, this node need one clip and the clip is coming out from the load checkpoint, but I use the Lora, so I have to use the clip from here. So now you know how to load the Lora in SDXL and also connect that to the clip text encode. Okay, we have that. And also for this node, I don't want to write my prompt in the clip text encode and I prefer to use node. Let me change the color to red and change the name to negative. And also on this node, I'm clicking and changing convert text to input and connecting it. Okay, so the configuration of this node is finished. I'm clicking here to close the node and also it's finished. So I'm clicking to close the node here. So my space will stay very simple and clear. Okay. And this is my negative prompt. Okay, move them here. For the sampler, I told you that I prefer to use the DDIM and the scheduler DDIM uniform. And at step 20, okay, so here now instead of writing some of these numbers like step CFG and other parameters, it's very better to connect them to a node. Okay, and after that we can configure the parameters in that node, and also we can connect that parameter into the other samplers, and this way is very better. So I'm right clicking, and from here I'm converting the clip end at a step to input. So for defining the end, I will create a node. I will convert the CFG to input, convert the step to input, and convert the seed to input. Okay, and how we can add and send some value to these nodes. Okay, this is the magic of the primitive node. Okay, this is one of the default node. Please take a look, go to the add node, go to utilities, okay, and add primitive. Before connecting the primitive to these parameters, make some copy, because once that you are connecting the primitive to output, to input of a parameter, it will change. For example, only you can write integer or float number or word or a string. Okay, and it's very important to copy them before connecting. It's very important, don't remember that. Now I can connect that. For example, the CFG is a float number, but the end step is a int number step, and also noise seed. And I have to rename them. This is end step. This is CFG. This is steps, and this one is seed. Okay, and let me change the color, for example, to purple, and place them here. Okay, so the end step was 20. Totally we need, for example, 24, 25 step or 30 step. Okay, the CFG value could be about 6.5, and the seed is okay. And for the base model, let me change the color to something like this, and now I need another sampler for creating the refiner. Okay, so here is the refiner. I have the checkpoint, and let me change the color to cyan. Okay, and I can make a copy from this sampler and also change the color to cyan, and in title refiner. This is base. Okay, and I have connected model to model. And now I have to add the CLIP text encode SDXL refiner. Okay, and it's for positive. So let me change it to green. And it needs some input data. Okay, and I told you that it's better to merge the both text, both G and also the L model, and after that send them to the SDXL refiner CLIP text encode. Okay, so for merging these two text, again I'm using to WAS suite, go to the text, and I'm using text list concatenate. Okay, oh excuse me, not this one. Also it's possible, but text concatenate. Okay, because these are not list. Text A, text B, so both of them went to this node. And after that, also let me change the color to green, and it can connect to the refiner. For the refiner, I'm converting text to input and sending them here, and minimize that. Okay, it need clip, and this is the positive. For the negative, we need something similar from here. Okay, and let me do it minimize. Here it need one input from clip and one input from negative prompt, and then I have connected to the negative. It's finished. Minimize that. It needs latent image. Directly I can connect the latent from the base to here. Okay, 1 minute. Let me move it here and connect the seed to seed, CFG to CFG step. So this time in the refiner, I don't want to define the end step, and just I want to define the start step. So let me change the convert end step to ViT. Okay, and the end step would be 1000. But this time the start step should be changed. So convert start step. Okay, and I'm exactly connecting this value to a start step. So if it is ending at 20, so it will start at 20. It's very easy, and if you change this value, both of these models will be changed in real time. And these are our total steps. Okay, and this is our refiner. Then we can add a VAE to the reroute. The reroute only helping us for moving the connection. It's something like a shortcut. Okay, and place it here. Send the latent to the VAE decode, connect the VAE to here, and save image. Okay, now we need some prompt, and let me copy paste my prompt. Delusion of a huge angry vampire like, and for the CLIP L. These are my prompts, and these are my negative prompts. I figure out that deformed distro, these are working, still these are working in SDXL. And cue the prompt. There is a problem. I forgot to connect the clip to here. Okay, cue that. Models are loading. It's encoding the text. The base model is processing our comment, our prompt, and then it is sending that to refiner. The refiner is continuing the job after step 20 up to step 30, and yes, it's the result. Okay, and now I want to send a result to a upscale. Okay, okay, so let me send that to upscale node. At first I have to add upscale model loader, select my model loader. 4x ultra sharp is working good. Also you can find some better. And after that, add upscale image using the model. It needs one image input. This is our image. And after that, we have to send the image to another node. The resolution of this image is 1024 in 1024, and when it is going to upscale, it will be 4048 in 4048. Okay, or more than a little more. But this resolution is very high, and we don't need 4x upscale. We need 2x upscale. So I'm sending the image to another node, image scale, by. Okay, and here in the scale by I am writing 0.5. So it is downscaling my image, and here I can write downscale. Okay, and after that, let me minimize this one. I can send the image to VAE encode, and I can use the VAE for encoding this image. Okay. But here from the base model I have a VAE, and also from refiner I have VAE. I prefer to use the VAE from the base model because I want to make the upscale with the base model. So send this to a reroute and move the reroute here. So it's our VAE. We can connect that here. And now we need a sampler. Okay, we need a sampler, and I think we can make a copy exactly from this node. I have a suggestion here, because also I need disconnected nodes. Okay, I'm pressing Ctrl C, and after that pressing Ctrl Shift V. So all the connection still are available. I'm connecting the latent to latent, model, positive, negative. I don't want the end step. Okay, end step. CFG could be same. Noise seed. Okay, so the end step is unlimited, and the started step can be 20. I think I can link this amount to start step. So here, let me change the convert start. Okay, so it will start at step 20, and it's trying to, it will help us to save some processing time and also memory. It's going to the end, and yes, I think everything is ready. I should send the latent to the VAE, but this time, because the image is larger, I am using the VAE decode tiled. Okay, and this node is working better for large image. It will take some more time for processing the image, but it will use very low VRAM, and also it needs a VAE. And here our image at a save node, and Q prompt. Okay, now this image is in 2048, in 2048, and you can see the processing speed is very good. It's very better than SD1.5, and you can see that it's in the VAE code. And also it's not bad to check my GPU memory. Let me open my task manager, go to the performance, and okay, for example, you see that only 7 GB of memory was used. Okay, one more time. I have to change the seed value to incremental, so it will change each time, and it can start the processing. So with this workflow, now it's using about 12 GB. I have opened many applications. The refiner is finished. It's about 10 GB. It's in upscale. It's 14 GB. Also, I'm doing video recording and other things. It's 14 GB. And once the processing is finished, it's going to the VA in the code, and you can see it's using very low VRAM. And we have the image. We have the image. Okay, so it's all here. You can set up your prompt. For the CLIP-G, it's better to define your art medium at first of your prompt. And for example, if I'm using the delusion because I'm trying to make something from concept, okay, and if I add delusion photo from starting of the CLIP-G prompt, completely the style of the processing could be changed. Okay, at first remember there's this style, okay, and now you can see it's going to be something very realistic. Okay, so when you are using the photo in your prompt, keep it in your mind, it cannot make something conceptual. When you are using the photo, it will create everything as the real shape and as the real dimension. But if you don't use the photo and for example you use the prompt some delusion or illusion or illustration, okay, after that it can create a concept art for you. And yes, it's a trick, and also I am sure there are many different tricks for working with CLIP-G, and the community will find all of them, and also I'm trying to explain them to you. Okay, it's ready. It's ready. The quality is good. Also, the resolution is fine. And yes, I like that. I like that. The food, this part has some problems, but I can accept the quality. Okay. If you have any question, please feel free and ask me. Hope to see you soon. Bye.